Hi, I'm Matt, and in this video we are going to go over how to identify organic functional groups. This video is part 2, as part 1 went over many of the common functional groups and went over what exactly a functional group is. In this video, we're going to move on and go over more complex functional groups that are less commonly seen. The types of functional groups discussed in this video are going to be hydrocarbons, functional groups where oxygen is single bonded to a carbon, functional groups containing sulfur, functional groups containing nitrogen, and carbonyls. You may realize that a lot of these groups were already discussed in part 1 of the functional group videos, but these are going to be additional functional groups not previously discussed. Before moving forward, it's best to reiterate some notes on notation that will be used in this video. In the structural formulas, an R will represent a chain of carbons or a hydrogen. If there are multiple carbon chains attached to another carbon, there will be multiple R groups, but they are not necessarily the same. So just because you see two R groups doesn't mean that they are the exact same chain. And in structures that would have resonance, meaning that the structure could be drawn multiple ways, only one structure will be shown for simplicity. So the first group that we are going to talk about are hydrocarbons. And the one functional group not included in part 1 are arenes. This is where a compound contains a benzene ring, as seen in the structure below, where it's a hexagon with alternating single and double bonds, and there could be an R group coming off of each end of the hexagon. A good example of an arene is 1,2-dimethylbenzene, where there is a CH3 attached to each point on the hexagon. The next type of functional groups that we are going to talk about are those where there's a single bond between an oxygen and a carbon atom. The first one we are going to talk about is a 1,1-diol. This is where there's a carbon that's bonded to two OH groups. So in the structure, we see that the carbon has two R groups coming off of it. It doesn't matter what those are. And then that carbon is directly attached to two OH groups. The next type is a hemiacetal group. This is where a compound contains a carbon atom that's directly connected to both an OH group and an OR group, as shown below. So here we see the carbons connected to two R groups that don't matter, connected to an OH, and connected to an OR. The last type we are going to talk about is an acetal group. This is where the center carbon, or any carbon, is directly connected to two OR groups, as shown below. So the 1,1-diol, the hemiacetal, and acetal groups are all very similar. But remember, a 1,1-diol has two OH groups, and hemiacetal has an OH and an OR, and an acetal group has two OR groups. The next group of functional groups that we are going to talk about are those functional groups that contain sulfur. One thing you'll realize as we go on is that many functional groups that have a CO bond, such as an alcohol or an ether, have a similar functional group that contains sulfur. This is because oxygen and sulfur are in the same group on the periodic table. So the first type we are going to talk about is a thioether. This is a compound where a sulfur is directly attached to a carbon on each side of it, as shown in the structure. And a good example of this is ethyl methyl sulfide, where a sulfur is attached to a CH3 and then attached to an ethyl group. This thioether is the sulfur analog of a regular ether that would contain oxygen. The next type is a thiol. This is the analog of an alcohol. So this is where a carbon is attached to an SH group, as seen in pentane ethyol, and the structure of this group you could see on the left. Then there's also a thioacetal group, where a carbon is attached to two R groups, and also is connected to two SR groups, as shown below. And the last type we're going to talk about is a sulfonic acid. This is where a carbon is attached to a sulfur that's connected to an OH group as well as double bonded to two oxygens as shown below. and an example of this is 1-propane sulfonic acid. And we could say that these acids will be very strong when they're dissolved in a liquid. The second to last type of functional group we're going to talk about are those groups that contain nitrogen. And we're going to start with imines, oximes, and hydrozones. These are all grouped together because they all have very similar structures. In an imine, it is a compound where a nitrogen is connected to a hydrogen and double bonded to a carbon. This is very similar to an oxime, but instead of the nitrogen being connected to an H group, that nitrogen is connected to an OH group, and then double bonded to a carbon that's connected to R groups. And the last type, a hydrazone, the nitrogen is connected to an NH2 group, and then double bonded to a carbon with other R groups. So all three of these are very similar, but they differ in what comes off the nitrogen. The next type is a nitro compound, and this is where a carbon is connected to an NO2 group, such as shown in nitrobenzene. So the benzene is the hexagon, and then the nitro group itself is the NO2, where the nitrogen has a positive formal charge, and each oxygen would carry a negative formal charge. The next type is a diazonium ion, and this is where a carbon is connected to an N2 group, and those nitrogens are triple bonded, as shown in the structure. A good example of this is methane diazonium, where a CH3 is attached to the N2 molecule. And the next type is an azo compound. This is where there's an R group that's connected to the double bonded N2, and there's another R group on the other side. So as we see in the structure, there's N2, and then each N has an R group attached to it. The last group we're going to talk about in the nitrogen category is a nitrile group. This is a compound where a carbon is triple bonded to a nitrogen, and then there's an R group attached to that carbon as seen in the structure. A good example of this is acetonitrile, where there's a carbon triple bonded to a nitrogen, and then that carbon is connected to other carbons. The last type of functional group that we are going to talk about are those functional groups that contain a carbonyl, or a carbon double bonded to an oxygen. The first type we're going to talk about is an acyl halide. This is where there's a carbon that's double bonded to an oxygen, and that same carbon is also attached to a halogen, which is fluorine, chlorine, bromine, and iodine. And in the structure below, the halogen is represented by the X. The next type we're going to talk about is an acid anhydride. This is a compound where an oxygen is connected to a carbon on each side, and then each of those carbons is double bonded to an oxygen, as shown below. An acid anhydride almost looks and is kind of like two carboxylic acids that the hydrogens were removed and started to share an oxygen. The next type we're going to talk about is an imide. This is very similar to the last one, except it's a nitrogen that's attached to a carbon on each side, and then those carbons have a double bonded oxygen. You'll also realize in the structure that it differs, since the nitrogen can be attached to an R group in addition to the two principal carbons. The next type is a carbamate or a urethane. This is where a carbon is single bonded to an oxygen that's connected to an R group, double bonded to an oxygen, and single bonded to a nitrogen that have two R groups as shown below. And it has to be that the two oxygens and the nitrogen are all attached to the same carbon. And the final type we're going to discuss in this whole video is a urea. This is where a carbon is double bonded to an oxygen and then also connected to a nitrogen on each side as shown below. Each of those nitrogens is attached to two R groups. Now that we've gone through all the functional groups, here are 4 multiple choice questions to test your knowledge of them. I will note that many of these questions involve the functional groups described in Part 1 in addition to the functional groups described in this video. The first question is, which of the following groups do not contain a nitrogen atom? a urea, an amine, an alcohol, or a nitro compound? Question 2, which of the following groups contain a carbonyl or a C double bonded to an oxygen? And your choices are alkane, hemiacetal, nitro compound, and carboxylic acid. Question 3, which of the following groups only contain carbon and hydrogen? An ether, an alkene, a 1,1-diol, and a halogenoalkane? And lastly, question 4, which of the following groups contain an oxygen atom? A benzene, a thiol, an azo compound, or sulfonic acids? At this time, I suggest you pause the video and the answers will be provided for you on the next slide. For question 1, the correct answer was alcohol, since alcohols only have an OH group, so they have no nitrogen. For question 2, an alkane, a hemiacetal, and a nitro compound do not contain a carbonyl, making carboxylic acid correct. And carboxylic acids have a carbon double bonded to an oxygen in addition to an OH group. Question 3, the correct answer is an alkene, since that is the only one from the hydrocarbon category. And then for the last one, benzenes only contains carbons and hydrogens, thiol only contains sulfur, and azo compound contains nitrogen, leaving sulfonic acid as the only one that contains an oxygen. Hopefully you got these. If not, feel free to list any questions you have in the comments below. And thank you so much for watching. Have a great day.